Imagine a world where your computer runs cooler, faster, and more efficiently. This is not a distant dream, but a potential reality, thanks to the innovative world of Magnon Circuits. Leading this exploration is Dr. Andrei Chumak and his team at the University of Vienna. They've developed a prototype processor that operates on magnetic excitations instead of electronic pulses. Magnon circuits harness spin waves, which are disturbances caused by the spin behavior of electrons. These waves can travel through specific materials, allowing information to be carried without the need for large electric currents. The potential applications of Magnon circuits are vast. In telecommunications, they could enhance signal distribution in 5G and 6G networks, providing better control over data routing. Designing these circuits is no small feat. Traditional methods are time-consuming and complex. However, by employing machine learning, engineers can optimize layouts more efficiently. Despite these advantages, challenges remain. Current prototypes are larger than most commercial chips and need to be scaled down to less than 100 nanometers for optimal efficiency. As researchers work to overcome these hurdles, the shift from purely electronic systems to hybrid platforms that incorporate magnons seems inevitable. Partnerships between academia and industry are crucial for accelerating the transition from lab prototypes to practical applications. The journey of Magnon circuits is just beginning, but their promise is undeniable. Stay informed and subscribe to our newsletter for more insights into this exciting field of technological advancement.